Hi everyone, my name is Prakash Adhikari, DBA student at California Intercontinental University. Today I'm going to present about visualizing the hypothesis testing, means looking at some graphical presentation of the data. Data says something, we get some hints to set up the hypothesis test. The agenda of this presentation is pretty simple and straightforward. We'll be discussing about the detailed anatomy about the bell-shaped curve. Normally the curve set up by the given set of data gives a lot of hints about the hidden hypothesis. Using a visualization to hypothesize about the mean of the data set, likewise the comparison of means and the comparison of mean efficiencies. And similarly, we will be using a visualization to hypothesize about the correlation of dataset for different variables. Let's go for the first case, test for a mean. Here, the curve seems perfectly symmetrical, and the mean is the highest point of this red curve. In y-axis there is the probability of defect, and in the x-axis the number of defective widgets. The widgets being non-defective, if you look at from the apex of this curve, being 0 is almost 40% from this graph. But what is the chance? What could be the chance that the company will be producing 100% non-defective or defect free? So there is a question that brings a hypothesis on the table. Then how we can set it up is the null hypothesis, mean defective not equal to 0. Here I am presenting my hypothesis in the verbal or words. It can be presented in the equation as well. And obviously the alternative hypothesis will be mean defective will be equal to 0, means all the production is non-defective. So to conclude the fact, we need to conduct the hypothesis test. We need to find the p-values. If p-values is less than equal to 0.05 level of the significance alpha, then the null hypothesis will be rejected and alternative hypothesis will be accepted, which will lead to the conclusion that mean defective of that production will be equal to 0, means all the production will be defect free. Likewise, in this graph, in y-axis you see the number of the home runs, and x-axis fraction of teams that are home run hitters. This compares to two graphs. Both graphs are symmetrical, and their average for the number of the home runs seems pretty similar, pretty same, but the fraction of the team that are home run hitters is different. So here is the research question. The blue is in the right side and red in the left side. So blue is the major league team, red is the minor league team. So looking at this, we can generate a hypothesis. The null hypothesis, the major league team is the mean of the major league team is not equal to the mean of the minor league team. Here the mean is the home run hit numbers, the mean for the home run hit numbers. And obviously the alternative hypothesis will be the mean major league team is not equal to the mean of the home run hit of minor league team. So after conducting the hypothesis test, we can see the hypothesis is statistically significant or not. Likewise, we can go to the efficiency of two server stations. The blue one has linear few servers, but the red one has also the queue is linear, but the servers are in multiple channel. Means it looks like red is more efficient than the blue one, but if we multiply the case, the hours top of the both have the curve, but they are skewed differently. The first one, red one, looks like very narrow, and the blue one is skewed wide, but both seems to be symmetrical. Here is the question: the mean efficiency of the red and the blue are equal, same, or different? They are statistical different. For that, we can obviously set up a very easy hypothesis model. For that, null hypothesis is mean efficiency of the red is not equal to the mean efficiency of blue. Likewise, the alternative hypothesis is going to be mean efficiency of red is not equal to the mean efficiency of blue. After conducting the hypothesis test, we can conclude if the null hypothesis is rejected or not, if the mean efficiency of red and blue are equal or not. And not only the curves, after visualizing some scatter plot of different data, we can set up some linear relationship there. The relationship could be defined by the correlation relationship. If how tightly or how closely these variables are related. If there is a very linear kind of the distribution, that shows the higher strength of the relationship. If more is scattered, comparatively loose. So R value defines the strength of the relationship. We all know that R value swings from -1 to +1. And R is equal to 0 means no correlationship, no relationship between the variables. So here in the given scenario, the research question is, what are the studies null and alternative hypotheses for the given industrial use bands and the weight of the industrial use bands and corresponding utilization of the gasoline. In normal general sense, we might think heavier the bands, they might utilize the gasoline. But we are not sure yet. To test this, we can set up the null hypothesis saying that there is no correlation between the gasoline utilized and the weight of the bands. Likewise, the alternative hypothesis will be there is correlation between the gasoline utilized and weight of the bands. So after testing the after conducting the test, getting the R value, we can say whether there is a correlationship or not. So after discussing all these curves, how we develop the curves, we develop on the basis of a given set of data. How we develop the linear relationship or something on the basis of given set of data. So after developing the curve or any graphical representation of given set of data, we can derive some kind of the hypothesis. So using a visualization, we can say that upon a curve can hint a possible hypothesis. Likewise, in case of the correlation test, straight line also can hint for the hypothesis. So in the hypothesis testing, null hypothesis and alternative hypothesis can be stated by the words, or also we can turn into the mathematical equations. We know that normally hypothesis Null hypothesis is stated before the alternative hypothesis. Thank you for attending my presentation. Thank you very much. You are more than welcome. If you have any question, please don't hesitate to ask me. Thank you very much.